Okay, so this is 2-7, solving absolute value inequalities, but I wanted to stop and review for a second solving absolute value equations, because there's some similarities in what we're going to learn today. So when we have absolute value of x minus 3 equals 10, and the absolute value bars are isolated, we write two cases, one with that number 10 and the other with the opposite sign, negative 10. And then you solve them and you get your two solutions. Over here, I had to isolate my absolute value bars first, so I subtracted 4 from both sides, and I got negative 2. An absolute value of any number will never be negative, so I couldn't even write my two cases at this point. The answer is just no solution. So here's our first example of an absolute value inequality. Step 1 would be to isolate the absolute value, just like we've always done. So I needed this plus 3 out of there, so I subtracted 3 from both sides. Now I still have my absolute value bars. A lot of you try to write this without the absolute value there, but that's what you bring down, and then 12 minus 3 was 9. From there, I can, step 2, write my two cases or inequalities. So my first one is the same thing as what's here with no bars. X is less than 9. My next one, I had to change both signs. It's like keep, change, change. I flipped my inequality sign and I changed the sign of the number. Since this problem started with a less than symbol, this is going to be a less than. It's an and statement. Since the original symbol was a less than, this is an and statement. So I know that when I draw my graph, negative 9 is smaller, 9 is larger, and I graph this, it's going to be an intersection without even having to think about it. Okay, so we have to write our answer as a compound inequality. Since this is an and statement, we had a less than symbol. This makes us a less than. So this is an and problem. So I need to write it as a compound inequality. We don't write the word and in between like we do with the ors. So we have our small numbers, negative 9, always the less than symbol, so it could be less than or equal to. X, less than the big number. Okay, here's example 3 now. So we have the absolute value of x minus 20 is greater than negative 13. I needed to isolate my absolute value bars. So I got that negative 20 out of there by adding 20 to both sides. Now I have the absolute value bars isolated, and I can write my two inequalities. So my first one is just a copy of what's up here with no bars. And my second one I had to flip and flip. Flip the inequality sign and flip the sign. So since this one was a greater than symbol, it's going to be greater than. That's an or. So when we have less than, it's an and. When we have a greater than symbol for the original problem, it's an or, and we need to make sure we write or in our final answer. So this is a word problem from page 144 in your book, example 3, so you can go back and look at this if you need to. When we have word problems, there's a certain format that we can kind of follow every time for these absolute value inequalities. It's always going to be absolute value of x minus some number, and in the word problem it'll be like what that number should be. So right here, should be 162.5. Close the absolute value. Then we're looking for some key words, like no more than, less than, greater than, at most, something that'll give us our symbol, which is, in this case, at most is less than or equal to. And then our last number, it's going to say something about how much that number that it should be can vary or differ. So it says here, it's acceptable for the pressure to differ from this value by at most 12.5. So that's how much it can vary, 12.5, and that's what we put there. And then I do want you guys to notice this is a less than in this case. So it's an and statement. So just like with absolute value equations, where we have it equal to negative 10 and it's no solution, that's a special case when that happens. So we're going to have the same thing with inequalities. So we have a special case with inequalities. Whenever we have a negative after our inequality sign, once we've isolated the absolute value bars, we ended up with a negative. When this happens, it's a special case, and you have to stop and think about it, that any number will be greater than a negative number. Any number that takes the absolute value will be larger than a negative number, like the absolute value of 2. It's going to be greater than -5. Absolute value of -2 will be greater than -5. Absolute value of 3 will be greater than -5, etc. Every single number. So we call this all real numbers, and you can abbreviate with this symbol. Okay, so over here on example 6, I isolated my absolute value bars and I ended up with a negative again. So another special case, but this time it's trying to tell me that an absolute value will be less than a negative. If it's going to be a positive number here every time because the absolute value, there's no way it will ever be less than a negative. So for that reason, this is no solution. So this is just a summary. Anytime you have absolute value greater than a negative, it's all real numbers. Anytime you have absolute value less than a negative, it's no solution. This right here needs to be memorized.